Hi, everyone. I'm Uri, and all those things maybe. Yes, but the main thing that I came here to talk today is like a few months ago, I was working or a year ago, I was working on a joint team together with Facebook on the second version of the GraphQL spec. And it ended up with this, which is was two RFCs to the spec and the reference implementation. One was done by Rob from Facebook, and one was done by me for GraphQL JS, basically to add the GraphQL subscriptions into the spec. And then we announced it as an official thing that everyone could use, even though in open source you can use whatever you want, official or not. So what I'm going to talk today is basically what is GraphQL subscriptions, why should you care about it, and also what it is not. Because when you work on a spec, then usually you need to think about not only what you want to put in a spec, but also what you don't want to put in a spec is even more important. But just before I'll go, and so my main goal today is to talk about real-time APIs. But every time I try to give the talk, I realize that there's a lot of context that people are missing about GraphQL. How many of you heard about GraphQL? Okay, it's getting better and better every time. How many of you are using GraphQL? Nice. It can be better. Hopefully by the end of this talk, more of you would use. So what is GraphQL? GraphQL is a query language. Means that I can query data. The most common use case is querying data over the network, but it's not the only use case. So I'll show a bit about that. The idea is that just by describing how your data looks in a schema, you can get very, very powerful tools, both at runtime while you're actually moving data around, and both at build time and development time. So how does it look? So let's look at the most common use case. I have a client, and I have a network, and then I have a server. And I want to get my data. So the first thing you can see here is kind of like this magic box in the middle. Let's call it a GraphQL engine. The only thing you need to tell to this magic box is this thing. It's basically how the data looks in a schema. And as you can see, it's a pretty simple schema. Like anyone can do that, including project managers. Like you don't need to be a developer to that. And yeah, project managers are great. Why are you laughing about them? So just by that, this tool, this GraphQL engine, can understand a lot about how to, and can give you a lot of possibilities. So the next thing that happens is that on the client, I can ask for just some specific thing that I need. Let's say the specific user and its name. So then this magic box will go in, interpret field by field, get the data from my data source, and return it back in one single response, just what I need, in exactly the same shape. So I know what the shape of the data that I will gonna get and the type of it. And this is also the shape that I want to get. I don't need to parse the data once it gets into my client. Now let's say I want something deeper. I want the messages of that user, and for each message I want the content. So now this magic box, let's call it, will get the user, but then get the messages. And then for each message, it's going to get the content. Now, the thing is, what if that content is actually coming from a third-party API or a service, like Contentful or something like that? That's not a problem. The only thing that developers need to specify is how to get each specific part of the data. And then for the client side, I specified how I want the data to get to me, and I get one single response in exactly the shape that I want, no matter how nested it is, no matter how many microservices or different things I had to do in the background, no matter if my server is Java or .NET or COBOL or the most advanced server in the world. The client doesn't care. Now, so this is very, very powerful. It's very, very powerful because when it was invented by Facebook, the problem was that they had really shitty servers, and they needed to come up fast with a great mobile application. It was in 2011. Maybe some of you remember that it's like HTML hell, but it was the HTML part was just part of the story. The main story was the data that they transferred in the earlier app was HTML. They were sending HTML data over to the clients, and they needed to move beyond that and have normal APIs fast without changing the server. And that's how GraphQL came to be. But there's more, because just by describing this data, I can get auto-completion, errors, while I'm developing. Now, some of you use TypeScript or Java or .NET, it's like, okay, I get it anyway. But you get it inside your own team, inside your own code base. This gets it over your API from a team you don't maybe even know, in completely different technology, and you still get type safety. You get it over the network, which I think is much more powerful. Like if some of you using TypeScript and are praising TypeScript, like the APIs are much more hell for you than your actual types inside your actual code. So this is very, very powerful. Not to mention you get full docs out of the box. But like I mentioned before, a bit, GraphQL works on any data. So I just showed you over the network, but what if I can do the same? This is Angular, but you can do it with React or Vue or whatever you use, or native iOS. But what if the data source is actually my local storage on my client? So I can still query one language for data, no matter if it's from the server or from my client. I need to learn just one way. I can write my UI in components. I don't need to write any code in order to wait for responses, in order to loop and structure them in the way that my UI looks. I just write a query in the shape that my UI looks, and I will just get the data in exactly the same shape. It saves so much code and so much bugs just from like repetitive, stupid work. And one cool thing you can do about it is like, I can now take and build like, let's say an MVP using GraphQL just for my UI. And then when I want to get it into a real app, I just take the same queries and push them to the server, and I have a real app. And I can even combine that. So I can actually make one query, and parts of those queries will come to my local storage. Part of the results will come from a server. So this is very, very powerful. Also, in some, let's say, JavaScript applications, some of us use Redux and stuff like that, and we don't have client-side schema. But here, I can have a schema with all its benefits, both for the client and the server. Yeah, so I can skip all of that because, so there's one more point. But let's say I have a server, and my server doesn't know GraphQL, which is not hard, but I don't know, for bureaucracy reasons or something, someone didn't agree for having a GraphQL gateway. That's not a problem, because you can actually use GraphQL on the client and call REST APIs on the server. So there's no more excuses why not to use it. Another thing that is very interesting that you do once you actually statically type your data is that you can co-generate a lot of stuff, both on the schema itself on the server and on the clients. So what my team basically did is we said, okay, the most common use case is I'll generate Java classes from those types, or generate TypeScript typings for that. But what if I don't know all the stuff that I can generate? Maybe I can build a whole ecosystem of people developing their own. So this thing is called GraphQL Code Generator. It basically gives you tools that you can just write templates and generate whatever you want from GraphQL. I have a complete talk about it that I won't go deep into here, but one example is I can actually write the schema, write some ORM information next to them, for example, like one-to-one, one-to-many, and basically generate a complete backend out of the box, works just by writing a schema that, like I said, product managers can do, not developers. So I have a demo of that in a talk that I gave. you can see that afterwards. But the main thing here is like, whatever we invented and templates we created, you can take them and build your own. Because each company has their own weird stuff. So, OK, so then there's like one more thing, which is actually the reason that I'm here, which is real time. And that's the main, I guess, the main topic for today. So real time is a complex, sorry, it's not a complex idea. It's just that it's a big word for a lot of different things, a lot of different use cases. And the problem is that some services are saying real time, but they don't split into the right use cases. And then it makes you sometimes use tools that are not the best for your job. So there's many things. For example, chat messages that you want to get messages in real time, presence, like is someone online or not. And then the important thing from this slide for me is that those are different use cases with different solutions fitted for everyone. Because usually when people think about real time, definitely in the web world, they think about this like magic box in the sky, in the cloud, that you just push data into your local storage and it syncs everywhere, which is great. And you can build apps really, really quickly, and you can have really cool apps that are collaborative, and you can do really cool demos in conferences. But usually, when you go to your main app and to be your big business, then you don't have a reactive backend. You don't have this magic box. You don't have database that tells you when it changes. And also, maybe you even don't have the ability to go and work with the cloud. You have to work with your own services, with your own shitty backends and legacy systems, but you still want to use the same use cases. So what do you do? So one solution, which is often considered not that good, but I don't understand why, is polling. Polling is actually a very simple, elegant, and good solution for many of those use cases. What is polling? It's just the simplest thing. I'll just send a request, and again, and again, and again, repeatedly. And that means that I know that the data that I see is updated, and I don't need to put in any like fancy infrastructure. So in a lot of use cases, it actually works, and that's great. But the thing is, what happens? The problem with polling is, first of all, what happens if there was a change between the polling interval? Let's say it's 1 second and it was in the middle of it. And what happens if nothing changes? You still periodically destroy your database or your backend services. So the next way of doing real time is publish subscribe. What does that mean? There's events. Someone tells me that there's an event happening, and I can respond to it. But how I can do that with my existing database or my existing backend? I need to set up some kind of like a pub sub engine that is connected to my clients all the time. The connection will stay there, and we'll go deeper into that in a second. But then what you can see on the left is just a regular event that happened, like a regular function that run. So for example, after we save something on the database, we have an event. It got saved. So we can use that event in order to tell the pub sub something happened. And then we can push data over there. So that means that every time a message added, I get an event, I can respond to it, and I can basically simulate, not simulate, I can actually live update my code. And that's a very good solution because I don't need a reactive database. I have the whole layer, all my data layer on top of my database. I know exactly the things that happen, so I can respond to that and update stuff in real time, even if it's like on the shittiest backend. But then there's some questions that we might ask ourselves. How do I know on the client what events can I subscribe to? Like it can change any day, and also, every time that event happened, how do I know what data I'm going to get? Like, it can be the message, the new message that was added. Maybe it's like 200 or whatever the hell the backend developer decided to send me. And maybe tomorrow it will be something different. Now, another thing, maybe the data that's being sent to me is too much, Like it's like all of the data of the messages ever, which is not good for me. But maybe it's under. It's not so much. It's not all the data that I need. And also, I have no safety between. It's like REST. I have no safety between what I'm going to get. I have no idea what I'm going to get. Well, all those three things sound very similar to the thing that I just mentioned like 5 minutes ago with GraphQL. Like GraphQL can basically, we can in the same schema, and this is the work that we've done. We thought, okay, how can we use GraphQL in order to solve more problems than what REST is solving? Because REST is based out of HTTP, but GraphQL is not based on a protocol. So it can work on WebSocket, it can work on whatever MQTT, whatever communication protocol you want to work with. It's just an abstraction. So with GraphQL Subscriptions, we said, okay, we can, the events that are coming from the server, we can describe them on the schema, and we can say what data I can query on or I can give on each of those events. And then the client can decide which events to subscribe to and get exactly the data that they need. And the most important thing that we set up, the goal for us was to be, not to be another service. It's an open source protocol, so it should work on any data source and on any event source. So let's see some examples how it works. So in my schema, I describe a subscription, a message added event. And every time a message added event, I can query the message. Now the client says, okay, I want to subscribe to a message event, but every time there's a message event, I want to get just the content and the author, not more, no less. So then, first of all, I establish a two-way communication between my client and my GraphQL saying And then what I'm going to do is I basically going to open like a port, saying to the server, every time this event happens, push it to here, into this function in my GraphQL server. Then every time this event happens, it's going to fire at the source, at the subscription, but then it's going to do the same process that we saw before with the GraphQL query. I'm going to get all the data that I need with this event, even if the event doesn't have this data. So even if, let's say, the author is coming from a third-party API, I can still get real-time push notifications or real-time publications with all the data that I need, even if it's more than my server has. And that actually means that it's very, very powerful because, first of all, I can put it over anything, and I can trigger that event from anywhere. For example, an IoT device. I can put an IoT device that will trigger real-time events, but every time it will trigger, it will get me all the data from my other servers. So suddenly I can build very easily a complete real-time application over whatever, over an old IBM infrastructure, which unfortunately I had to do at some point. Yeah, and again, like it can be an IoT bridge, the source, but it can be a server function and maybe webhooks. Like webhooks are actually it's becoming more and more of a good use case for GraphQL subscriptions, or common use case for GraphQL subscriptions. Now, I don't have a lot of time. I have a lot of slides here about what are basically the challenges when you go into real time, because when you go into real time, you have more issues to know about. My main message is in those slides, in the next slides, is basically there are solutions for that. But I think I'm going to basically jump through that really quickly because I want to hopefully get to time for questions. But first of all, I gave a similar talk before, so you can Google it. And yeah, and I'm here for those types of questions. But I'll just run through it pretty quickly. So when you go into production environment, one thing that we mentioned is there's three major concepts to think about. Bidirectional data over the network. I can't just use HTTP anymore. Well, we'll talk maybe a bit about HTTP, but I need to get not only the client to query stuff, I need the server to push stuff for me. The other thing that we need to think about is what happens if I go offline now, and then I go back online. How do I keep my app operating? And how do I get back all the stuff that happened before? And the third part is scaling. Now, it all can sound very fancy and very hard. The truth is there's a lot of open source solutions out there, and the main reason that for you it sounds hard is that most of the people that talk about those things are people coming from services companies and backend as a servers companies, that their goal for you is to think that their solution is the easiest possible, and everything else is the hardest possible if you do it yourself, because you need to pay them money. My goal here is to tell you it's okay to use services, but wrapping them around open source standards is not that hard, and there's more, and the main companies, the biggest companies today, they don't use services. Like Facebook doesn't use Firebase for the real-time stuff. They use open source tools. So yeah, bidirectional transport is one problem, but there's a lot of solutions, like WebSockets is very, very common solution. If you can't do that, you have server-side events, which is kind of like something weird in HTTP. You can do HTTP load polling, you can do MQTT, like basically over like mobile devices. The idea here is there's a lot of, I won't dive too deep into that in terms of time, but there's a lot of existing solutions for that. You don't have to use a one-size-fits-all service to use that. Another thing is offline. So what happens if I'm now going offline? How do I recover? How do I save my local cache? And in my opinion, if the API between you and the backend is not proprietary with a service, but it's open source, you can actually use existing solutions and existing SDKs that are completely open source, and probably the best because most people are using them, in order to solve this problem. Why would you use the local data store of Firebase when you can use like Relay or Apollo Client, which are completely open source, being used by many more people for many more use cases? And when you go to scaling, I think that's the most interesting part, because when we go to scaling, the main difference is now we're becoming stateful. We need to know, like the server needs to basically know who is connected to me and what they need and what they have already or not. So I have this whole architecture slide. I really hope to not to go too deep into that, but basically what I want to say is that the GraphQL servers themselves are stateless, exactly like REST. And that means that you can scale them horizontally and then put in some kind of like a pub/sub mechanism like Redis or Kafka, or even if you want to use a Redis like Pusher or whatever you want to use, that's okay, in order to get messages into one theoretical source and then distribute them throughout all your hundreds of GraphQL servers. And then the same thing goes into the event source. What happens if I have tons of events flowing into my GraphQL servers? I want to also scale those events and split them correctly between the GraphQL servers. And there's also, when you get into like your actual data source, there's many ways of like scaling databases. This is a known problem. So again, I didn't go too deep into that, but the truth is that there are solutions, and if any junction in the point, you have open source protocols that supports that, and that was the main reason I joined the GraphQL subscription team or spec team, is that you can use existing libraries, but you can also use services where they belong. Now, the last concept or way to do real time is live queries. It's kind of like what we mentioned before, is those magical things that I can just say, this is the data that I want, just update it whenever it gets updated. And it sounds magical, but if we think for a second about subscriptions, what I said right now, it's kind of in the middle, and it can give me more power if I want, because I can say, I want to subscribe to those events, and with those events, I want to get this data, which is almost like live queries, because I get the data itself, but I also can respond to the event. So it gives me more power to do what I want. I can, instead of just pushing a new message into my chat, I can put it into animation, I can submit like a push notification, I can do whatever I want to respond into that. I can delay it. I have more power. So what you would think is like, okay, live queries is kind of like the simplistic way for me to build something simple, and that's true. But it's also, sometimes it's actually the other way around. What if the events that I want to subscribe to are just too much? For example, Facebook, the way they use live queries is updates on a like of a post. Because updates on a like of a post, you would say every time someone liked. But what happened if someone disliked it? What happens if someone closed their Facebook account? I also need to update it. What happens if someone now is not my friend anymore? I need to remove them from the list as a friend and put them as just some other person. So there's many, many events, and in that case, I want something else. As a client, I just want to subscribe to the number. I don't want to know anything. So what I'm showing here right now is something that I've built an implementation for, but it's not already in the spec, but you can still use it because it's open source. So what I do here is the client queries for a query, regular query like we saw before. But what I'm saying is the content, please keep it live. Just keep this thing live. So then I will send the same query as I said before, like I will get a response, I will send the query back, everything is fine like before. But then the main difference is that once I got my query back, I still have an open connection to my client, and I still have an open connection to like magical database. And then when something will change in the magical database, then this data will flow just from this magical database into the client, and I will get just the delta of the data that was changed and the path. And this is in the spec. So it doesn't matter if my magical database now is Firestore, RethinkDB, Meteor, or if you're using the latest Mongo 3.6, then you can actually use change streams, which is a new feature there. So I think my main message here is basically there are a lot of solutions out there. There's like the companies, all those companies that I mentioned and the solution that I mentioned are great. They're doing a great job. But what I'm calling you is basically use the right solutions in the right places and put open source protocols between them all. Because then you can take Firestore, which is an amazing solution, but use it as your database instead of like the whole server communication system, which is probably something that you won't be able to do in a big, large company. So to check, I have many, many examples on that on my GitHub, like applications, like everything that I've demonstrated here. And my main call for you before questions is just encourage your service developers, your service providers to use open source standards also for real time, because now you can. Thank you. There's time for questions?
Okay, we have some time for questions. So let's start with first one. Is there any situation where you would not use GraphQL but use REST instead?
Okay, so that's the hardest question for me to answer, because when someone comes in and you're going to tell them about new technology, you won't be reliable if you say there's no reason to. But I haven't seen a lot of use cases where GraphQL wasn't more suitable for REST. I would say that today REST is much more popular. So if you have a third-party APIs, you will have to expose REST no matter what.
Yes.
But there are solutions for that as well. For example, with this GraphQL codegen that I showed at the beginning, we can actually build this like template where we generate REST APIs from GraphQL. We basically take the GraphQL schema, generate Swagger schema, and then you can use the whole Swagger like ecosystem to generate REST APIs. There are also a lot of things, I won't have time now, but there's a lot of things and misconceptions about GraphQL, because everyone thinks like the client can query whatever they want. that's not the case. You can limit, you can whitelist, you can basically click and cache just like you would do with REST. But
Okay.
yeah.
Next question. What about GraphQL with PWA, so with progressive web apps?
So PWA is a very cool word for a lot of different things. And like everything that Google pushes, it has a lot, and it's a lot of marketing behind it. So there's few things that you can do with it. Like one thing is that PWA, there's one thing that says you want to load a web app as fast as possible. I would argue that the data is not less important. Everyone thinks about the bundle size of their app. They don't think about the data that they're sending. But this is as important, in my opinion. The other thing is that PWA is, for example, you have the opportunity to run a service worker. So with Apollo Client, for example, you can write all Apollo Client, including the store logic and the network requests, running in a service worker, completely separated from your web app. And then also, of course, all those requests could be cached. And the third thing is like SSR, like server-side rendering. Like you can hydrate the Apollo store or the Relay store and then like just send HTML with the data to the client to render it as fast as possible.
Okay, and the last question for today, how secure is GraphQL?
It's a great question. So few things. Like people, first of all, when they talk about security, they think about the fact that the client can query whatever they want. Well, the first thing is that the server exposes the schema in order for introspection. So for that, usually what you do is when you expose the introspection schema only in development time. You never expose it in production time. The other thing is that if you're not using public GraphQL APIs, which is a different subject, then you would never, in my opinion, expose the stability. You basically, in development time, you can query whatever they want, but then when you build your app, you basically take all the queries from the clients and build a hash on the server, and then all those queries on the clients basically being generated into IDs. So what you've done here is, first of all, you whitelisted the requests, so you have basically like REST requests, like fixed requests that you know what they're going to come. They have special IDs that it's it's harder to find. It doesn't say anything about the data that goes through the transport. And it's also much faster because you don't need to upload all the query every time, but you upload just IDs. On the server side, authentication is just like any other server. Like GraphQL, you can look at it as kind of like a gateway. So you can secure underneath the gateway in your model layer, for example. And then you can, but the interesting thing there is that, let's say I query a user age and a username. So I have the permission to take the name, to get the name, but not the permission to get the age. With REST, I will probably send like 403 or something. With GraphQL, I still would be able to send back a partial response. I can send back the name and send null on the age with an error saying you don't have permissions for this field. So it's actually more resilient into those types of ways of security.
Okay.
Yeah.
Thank you very much.
Thank you.